The first trend we'll talk about that relies on electron configuration and effective nuclear charge is atomic size. The book uses the word atomic size. I prefer the word atomic radius because size, you might think that something that is heavier will have a larger size, right? We're not talking about mass here. We're just talking about volume, radius. Okay, so atoms get bigger as you approach this corner on the periodic table right here. So this is the biggest corner. So that's something that you can just remember. The bottom left corner is the biggest atoms on the periodic table. Because the trend is size increases as you go down a group, and as you go from left to right, size decreases. The radius gets smaller from left to right, even though the atomic number, the number of protons and neutrons and electrons, is increasing. So it's important to understand why that is. So I made this figure here to illustrate. So the first trend is the radius gets larger as we go from top to bottom, as you go down in a group. So hydrogen is smaller than lithium, lithium smaller than sodium, so on. And that's just because every time you go down, you're adding another shell of electrons. Another layer of electrons is getting added on. Lithium has 1s electrons and 2s electrons. Sodium has electrons in n equals 1, electrons in n equals 2, and an electron in n equals 3. So that should make sense. As we go down each row on the periodic table, we're adding another shell, so they get bigger. It's a little bit maybe not as obvious why atoms tend to get smaller as we go from left to right, even though we're getting more protons, neutrons, and electrons. The reason is that we're not adding any more shells. So the valence electrons are still in the same shell. And so, for example, as you go from boron to carbon to nitrogen, you're stuffing those new electrons into the same place, really, the same shell. And at the same time, the effective nuclear charge being felt by those outer electrons is increasing. So I'm showing this the purple color getting more dense because we're adding more electrons into that, and the effective nuclear charge felt by that valence electron, those valence shells, is larger. It pulls those valence electrons in closer to the nucleus. Same thing we see here. Sodium only has an effective nuclear charge of +1. So its one valence electron has a little bit of freedom. It's not as strongly attracted to the nucleus. But argon has an effective nuclear charge of +8. So its valence electrons, even though there's 8 of them, they're feeling a much stronger attraction from the nucleus, and so they're pulled in tighter, making it a smaller atom. Right? So remember those two things. Size increases going down because more shells. Size decreases going to the right because of two things. Effective nuclear charge is increasing, but the number of shells is not.